So we're now going to take a look at the ex2 source code and walk through a part of it. And this code is much more interesting than the ex1 case study in that it's going to show off a bunch of RxJava features dealing with asynchrony. And it's also going to demonstrate boatloads of really cool RxJava operations. So we're going to focus initially on the test is prime timed method, which will test a stream of random big integers to determine which of these values are prime using an asynchronous time-driven observable stream. And then we'll come back later and talk about test is primed async. So let's go take a look at test is prime timed. You can see that this appears in the observable ex class. And if you take a look at the class, it's got some helpful fields defined. It has the maximum random number value, which can be up to 10 million, as you can see here. The maximum number of iterations to run in the test, which is 10. And then the lower bound, which is the starting point of the randomly generated numbers we're going to use. And we do this in a way that's going to end up ensuring duplicate values. We'll see why we need to do that in a second. Here's the random number generator. It's going to be used to generate the random numbers. And then here's a really cool field called M prime cache. And this is a concurrent hash map. And this is going to be used as something known as a memoizer cache, which is just a fancy $64 word that says, make sure that we keep track of the primality of candidate prime numbers by storing them in a map. So if we get the same request for the same prime candidate later, rather than having to perform some expensive recomputation, we'll just look it up in the map and give back the value right away. So what gets stored here are basically the keys, which are the prime number candidates, and then the values, which are going to either be 0 if it's a prime number, or the smallest factor if it's not a prime number. Now, and then one more field here is a duration that keeps track of the amount of time we're going to sleep for the timed version we're going to do first. So this is going to be basically a half second. This takes a while to run, so I'm going to go ahead and start running this. But while it's running in the background, I'm going to go ahead and walk through the code. So we're going to start by talking about test is prime timed. And as I said before, this is going to use this asynchronous time-driven observable stream that will process random big integers to determine which ones are prime or not. We start out here by making a string buffer in order to be able to keep track of the diagnostic results we want to print out when all is said and done. Unlike our previous example that used a string builder, which works only in single-threaded synchronous code, we're going to use a string buffer because that works in thread-safe code. If we have multiple threads, it does synchronization properly to add and append elements to the string buffer. And you'll see why we need this in a second. All right, so here's our observable stream. You can see it's got a bunch of stuff going on here. And we're going to start by taking a look at observable create. Create is this factory method that's passed in essentially an emitter. And we're going to pass in something called emit interval. And here is emit interval. Emit interval takes an observable emitter parameter called emitter. And what it's going to do is it's going to use the interval method on observable. So remember, interval will go ahead and generate a long, starting at 0, every duration amount of time. So in this case, we're going to say every 500 milliseconds or every half second, generate the next count. Now, in this particular case, we could care less what the count is. We just want to have this thing pulsing like a heartbeat once every half a second. So every half a second, a number will be generated. We're going to ignore that number using this little __ idiom, which I use to mean I don't care about this value. And then we're going to use the map method to actually generate the next random integer. So we're going to generate a random integer between lower bound and S random next int max iterations. So this is the upper bound. So we're basically generating numbers within a range up to essentially 10 million. And the way it works is we're going to guarantee some duplicates, and you'll see why we need to do that in a second. So we've now got a stream of duplicates that are being, a stream of big integers that are randomly being generated, some duplicates, some not. And those will then be put through the rest of the elements in this stream. And the next operation we're going to apply is the filter operation. And we're going to use this in order to get rid of anything that is an even number. Because of course, it doesn't make any sense to check the primality of an even number because even numbers couldn't possibly be prime because they're always evenly divisible by 2. So here we're going to take our big integer, and if it is modded by 2 and it does not equal 0, then we know that it's going to be odd. But if it is modded and it equals 0, then we know it's even, and we're going to skip it. We then use the take method, because remember, interval will go on forever, but we only want to do S max iterations of these things. There are 10 of them. So we're going to limit ourselves to 10. And then the final method here is the subscribe method. And you can see the subscribe takes 3 parameters. It takes emitter on next, and that's used to pass back the normal case. That's just the next non-even randomly generated big integer. Here is another lambda expression that says if an error occurs, just complete. And then if complete occurs, just propagate that along. So that's what subscribe is going to do. Now note, this is not blocking subscribe. This is subscribe. So subscribe will return, and then the interval will be chugging out those events every half second in a background thread. And by default, that background thread is going to be running in the scheduler's computation thread pool. So that's where that's going to come from. Okay, so now if we pop back to where we called this stuff to begin with, you can see that create was passed emit interval. So that will then start this processing in the background. And then those events will be propagated through the rest of the operations in this particular observable stream. So these calls will all take place in a background thread. And I'll show you that in a second when we look at the output. So the next thing we're going to do is we're going to call the doOnNext method. Remember, this is the one that just registers a callback, doesn't change the results, doesn't filter, doesn't modify, doesn't change the type. It just, in this case, will print the value out as a debugging aid. We then call the map method. And what map is going to do is it's going to check to see if that big integer is prime or not. So let's go ahead and take a look and see what the checkIfPrime method does. The checkIfPrime method takes the prime candidate, and it goes and it looks up in the prime cache. This is that memoizer cache I was telling you about before. And what this does is it calls the super cool atomic check-then-act method compute if absent. And this is a method that's defined on concurrent hash map. And what it will do is it will do the following in a thread-safe way. So you can have multiple threads all doing this simultaneously. And it'll check to see whether the prime candidate value is already in the cache. If it is, it'll return it. If it's not, it'll call this mapper function. And this mapper function, which is defined down here, will check to see if a big integer parameter n is prime or not. So this is actually the code that you could write if you wanted to check to see if a big integer is prime. And this is intentionally designed to be super slow, just because we're trying to grind out and burn CPU time just to show how this all works. And so this goes ahead and computes to see whether the number is prime, in which case we get a 0 back, or if it's not prime, we'll get back the smallest factor. So that's what the isPrime method does. That's called from compute if absent. That returns something called a prime result, and prime result is a class that keeps track of the prime candidate and the smallest factor, which could be 0 if it's a prime number. And it's just basically a tuple that keeps track of those results. So that's what comes back from checkIfPrime. So you can see in this case, map takes in a big integer and it returns an observable of prime results. So then we use the doOnNext method again. This is the second call to that method in this stream. And we go ahead and we process the result, and the processed result just prints out whether it's prime or not. So just a little debugging aid to kind of give you some sense of what happened. We're almost done, but there's still a few more steps. The next method we call here is called doOnComplete. And doOnComplete is very interesting. What doOnComplete does is it will basically be called once and only once in the life of a stream when the onComplete signal is received. And so you can think of this as kind of like a destructor, if you will, or a finalizer. And what it's going to do is it's going to trigger displaying the contents of the string buffer. So we want to do that once and only once, and we want to do that after everything else is done. So doOnComplete handles that at the very end of all the processing. Then just a couple more things. The next thing we do is we use the count method, and the count method converts the observable into a single. And the single, of course, is going to contain the count of the number of elements that have gone through the stream. And we do this primarily so we can then turn around and ignore the result. And we use ignore result to return a completable, and that will then be used to synchronize with the async tester framework. So the real purpose of that was just to get it to the point where we could trigger something that the async tester framework would know about as an indication that we're done with this asynchronous test, and then that thing can return. And after all the asynchronous tests are done, then the main program can return. We don't want it to return until everything is done. So that was essentially a walkthrough of the test is prime timed method. Now we're going to come back shortly after we talk about some other RxJava operations, and we'll talk about test is prime async, and that runs things in a different way. And when we do that, I'll also show you the results and compare and contrast them between the two examples.